Uh, Good morning. So today I'm going to discuss about the Maxwell equations in biochemical thermodynamics. So the aim of this session is to understand the Maxwell equations. The main objective of this session is students can able to understand the significance and the theory behind this Maxwell equations. Okay. So the ultimately students can learn the concept of the Maxwell equations and the significance of Maxwell equations. So who is this Maxwell? He is a scientist born Edinburgh, Scotland. He is a physicist well known for his work in electromagnetism and field theory. So also known for his work in thermodynamics and the kinetic theory of gases. Yeah. So why use this Maxwell relations? This Maxwell relations provides the way to exchange the variables, natural variables into energy variables, like what we discussed in the previous session, fundamental property equations like reference properties can be transferred into energy properties. Energy properties can be converted into partial differential forms of the equations. Okay. So as we know that in thermodynamics many variables are there. Those are classified into primary variables or reference variables, or second one is secondary category variables or energy properties. Third one is derived properties. All these three categories of thermodynamic properties are there in biochemical process. So these variables like pressure, temperature and volume can be measured directly from the experiments. Some other variables like internal energy, Gibbs free energy, Helmholtz free energy, enthalpy cannot be measured directly. So by knowing pressure, temperature, we can estimate the energy properties as well. So these relations can be explained by the Maxwell. So before going to this Maxwell, let's see some importance of the Maxwell. Since Maxwell equations are very useful in replacing unmeasurable quantities by using measurable quantities in thermodynamic equations. So using these equations or these relations, the partial derivatives of entropy with respect to pressure and volume are expressed as a derivatives possessing easily identifiable physical meaning. For example, du is equal TdS minus PdV. These are replaced by the partial differential form. This is the first fundamental property equation. This can be defined in terms of the partial differential form in terms of temperature, pressure, volume and entropy. So let's start with the first Maxwell equation. As we know, there are four Maxwell equations. Let's start with first Maxwell equation, like from the first fundamental property relation. du is equal to TdS minus PdV. This is called the first fundamental property equation. That can be converted into first Maxwell equation. If you look at this one, so dou T by dou V is equal to dou P by dou S. Minus sign is there, that's why minus sign will come. If you look at the first fundamental property equation, du is equal to TdS minus PdV, that is converted into first Maxwell equation. How do you get this one? Dou T by, what is Maxwell equation? These are the partial differential form of the fundamental property equations called as the Maxwell equations. So this is the first fundamental property equation which is related to internal energy in terms of TdS minus PdV, that can be converted into partial differential form. Dou T by dou V is equal to minus P by dou S. apply the constant at entropy and at volume. Okay, this is called the first Maxwell equation. Similarly, let's see the remaining three Maxwell equations. So, if we take the second fundamental property relation, which is related to the enthalpy, dH is equal TdS plus VdP, that is converted into partial differential form dou T by dou P is equal dou E by dou S. How to get this partial differential form? Similarly, so dou T by dou V, dou T by dou P is equal to dou V by dou S. Apply the at entropy S at entropy P here. Apply the remaining variables here. This is called the second Maxwell equation. Similarly, third Maxwell equation. What is the third Maxwell equation? It is a work function or Helmholtz free energy equation. This is derived in terms of entropy, temperature, pressure and volume, right? This is what derived as a third fundamental property equation in the previous class. Let's convert this equation into Maxwell equation. So, dou P by dou T, you can write as well as dou P by dou T as well as dou S by dou V. This is called the third fundamental property equation. So, there are both side negative signs are there, signs will be cancelled. You can get the dou P by dou TV or dou S by dou T. Otherwise, we can write down the dou S by dou V, similarly dou P by dou T. Either way, we can write two ways. Similarly, now we can write down this fourth Maxwell equation, which is related to Gibbs free energy. The change in Gibbs free energy is equal to minus S dt plus VdP, right? So, in the form of the partial differential form, dou S by dou P is equal to dou S by dou P is equal to dou V by dou T, dou V by dou T. So, the partial form, right? So, there is a minus sign, just put one minus sign here where S comes, delta dou S comes, we can get the fourth Maxwell equations. So, these are the first Maxwell equation, second Maxwell equation, third Maxwell equation, fourth Maxwell equation. These four Maxwell equations are the partial differential form of the fundamental property equation. All these left hand side, these are called as fundamental property equations, and right hand side equations called as Maxwell equations. The differential form equations called as fundamental property, and partial differential form equations called as Maxwell equations. So, easy way we can